Hey, this is Ken Roosevelt, and we're going to look at how to solve these systems of equations by substitution. I gave you two of these in the old Unit B test, and I said you need to solve these systems by substitution. So I didn't really give you an option. So we're looking at the substitution method. First thing you need to know about solving a system of equations, I mentioned in the previous video, is that we're looking for the one ordered pair, or maybe there's more than one, that works in both equations at the same time. And because of that, because we know that the xy up here is going to be the same as the xy down here, because we're working off that assumption, we're allowed to do substitution. We're allowed to say, hey, this equation says that y is equal to this over here. Y is equal to this. Well, there's a y in here. And the beauty of substitution is we can take this y out down below and replace it with this up here. Now, why do we want to do that? Because you can't solve an equation that has two variables in it. This equation up top, this one here, infinitely many solutions. How do they look? When you graph all these infinitely many solutions, you get a line. What about this one down here? Also has infinitely many solutions, but because their slopes are different, because equations are not multiples of each other, we're going to find one point that they have in common. Alright, anyway, so let's do it. We're going to do substitution here. How am I going to do that? I'm going to take the y out of the second equation, and I'm going to replace it with what I highlighted in the first equation. So there we go. And now I'm just going to simplify. And now what was a two-variable equation has now become one variable equation. And I can solve it because it's just a simple linear equation in one variable. Here's where most people make the mistake if they make one. It's negative 4 times negative 2x, so that's a positive 8x. So now 3x plus 8x is 11x. Let's add this 20 onto the other side. Gives me 22. And dividing both sides by 11, 22 over 11 is 2. Once we know x, though, we're not done. We have to find y, because the answer is an ordered pair. So I'm going to plug it into the equation I perceive as being more simple. And I'm going to plug in x. X is 2. I'm plugging it into that equation, and that gives me 5 minus 2 times 2, 5 minus 4 is 1. So the ordered pair, which is a solution, is 2, 1. And there it is. Now, I'd like to encourage you to try this one yourself, but let me just point out, in this equation, or this system over here, we already had one of the equations solved for y. So it was obvious that we were going to make this substitution into there. This one, not so obvious, but a piece of advice is you generally want to solve for the variable that has a coefficient of 1 or negative 1. So here you have 4 variables. You can solve for any of them, but the one you want to solve for is the one that has the coefficient of 1 or negative 1. So probably you want to solve for this one or this one and substitute that result into the other equation. Try it on your own. Take a couple minutes, pause the video, and we'll be right back. Alright, we're back, and my plan is to solve the second equation for x, because all that entails is moving this to the other side. So I'm going to say negative 4y minus 5 equals x. And this is going to go in to the second equation. Where's it going to go? This right here is going in there. Alright, let me grab black. 2 times that quantity minus y will equal 8. What's that quantity? It is negative 4y minus 5. Be sure you're keeping track of your signs. 2 times negative 4 is negative 8y. 2 times negative 5 is negative 10. Minus y is 8. If we add 10 to both sides, we'll have just y's left on the left side. That's an 18. That's negative 9y. And the result is 18 divided by negative 9 is negative 2. Well, we're not done, right? You found one thing, you found y, awesome. We still have to find x. Pick an equation, I'll use the top one. It doesn't matter which one you use. Just make sure that you plug in negative 2 for y, not for x. Just a couple minutes ago I did this video and I plugged it in for x on mistake. So make sure you plug that in for y. 2x minus negative 2 is plus 2. Minus 2 from each side gives you 2x is 6. So x is 6 over 2, which is 3. The solution is an ordered pair, and it is 3, comma, negative 2. And that's how you do these. Substitution. You find the variable which has a coefficient of 1, preferably, or negative 1. And you solve for that variable and you substitute into the other equation. Let me make one final comment about this. When you're solving systems of equations, sometimes you will get a result which is a ordered pair, but sometimes you'll get your linear equation after substitution will reduce to something like 0 equals 5. And 0 equals 5 is a contradiction, and what that means is there's no solutions. So you would put something like that, an empty set, or like this to represent the set of solutions. What this means visually is that you have two equations. The graphs of these equations don't intersect. Their slopes are parallel. So this would be the case of an inconsistent system of independent equations. I apologize for my handwriting. Independent. Yeah. And we generally just call those inconsistent because there's no solution. The other possibility is you'll solve the system and you'll get an identity, something like 0 equals 0. All the variables will cancel out. Instead of being left with a contradiction, you're left with something that is a matter of fact, like 4 equals 4 or negative 8 equals negative 8. In such a case, that means you have infinitely many solutions. But remember, our solutions are ordered pairs. So you can't just say infinity to infinity because it's not a one-dimensional number line. It's a two-dimensional coordinate plane. So you have to say specifically, where are the solutions? I know there's infinitely many, but where are they? And the answer is, when you get an identity, when you get infinitely many solutions, it means both of your equations had the same graph. And so how many places does this black line intersect this green line? The answer is everywhere, but not everywhere out here or out here. Everywhere on the line. So when you have an identity, you have a consistent system of dependent equations. I'll write that. This is called consistent, dependent, and you can just call it dependent. And what that means is you have to write your set of solutions as follows, where you would actually write the equation there. It doesn't have to be in general form. It could be in slope-intercept form, whatever form it may be in. So let's say this was y equals x plus 2. Then the set of solutions are the ordered pairs such that, or with the condition that y is equal to x plus 2 is what you would put over here. This is called set builder notation. Over here we see what form our solutions take. Our solutions are ordered pairs. And then after the line comes the condition. And the condition in this little example I just made up is that all the points that are considered to be solutions are on this line. Oh, by the way, if they just intersect, what do we have there? We have a consistent system, but it's independent equations. So consistent, independent is when you will get an ordered pair solution at the intersection. All right, I hope that helps. Adios.